Hello, I'm David Reeves, host of the TV show Creation in the 21st Century on TVN. Each week we talk about breaking discoveries in science which reveal that our Creator, the God of the Bible, has left a pattern of His fingerprints throughout the universe. Check us out and sign up for email updates at davidreeves.com. Subscribe to our free monthly magazine and like us on Facebook for weekly inspiration and education regarding science and the Bible. Science, mathematics, and beauty. How do these three connect? Why would something entirely abstract ever be found in nature? Well, when you see the connection, you'll be blown away. This is Wonders Without Number. Welcome to Wonders Without Number. I'm David Reeves, and today we want to inform and inspire you regarding the wonders we find all around us. An infinite number of wonders that point us directly to our Creator, the God of the Bible. Now, you're no accident. I want you to know that you are special, that you were created in God's own image, that Jesus Christ was and is that Creator, and that He has a plan for your life. We find great beauty all around us, but with that beauty, we also find design. Let's take a look right now. Think about it. There's great functionality in design. Take, for instance, a skyscraper or an ice cream cone. Both are designed to efficiently contain some element. One allows a scoop of ice cream to be held in an edible container, while the other design allows a relatively small footprint on the ground to hold thousands of people. But good design doesn't stop there. Design is also beautiful. Think about it. The most carefully designed structures are also the most aesthetically pleasing to our eyes and other senses. A sophisticated jet, a palace, an expertly crafted dessert, a symphony. But let's not stop there. A rose, a hummingbird, your family pet, even the fierce beasts of prey, human life, microscopic DNA, our planet, and our universe. All of these things have great beauty and even greater functionality. Every example of beauty and positive functionality requires thoughtful design. While we can go back to historical records to track down the original designer of each man-made invention, we can also track down the designer of the entire natural world, including you and me, by reading the history that we find in the book of Genesis. Not only can we revisit the creation of the universe in that record, but even today, we can know the Creator Himself. We all enjoy the use of phones, but it's too late to meet Alexander Graham Bell. What about cars? Not much of a chance of catching up with Henry Ford. You might like Facebook, but you'll probably never get a face-to-face with Zuckerberg. But we enjoy so many other things, like sitting on our porch watching the sunset, or the smell of rain, or taking a deep breath of air, or the feel of water splashing around your feet. Just like all of the other man-made functions and designs we've discussed, these elements of nature and the very senses we use to connect with are all elements of design and complexity, beauty and functionality. I'm David Reeves. Truly, the heavens declare the glory of God. When it comes to science, a lot of people just take God out of the picture. But many people in various fields of science believe that the God of the Bible created the universe, including the laws of science and physics. Not only that, but many believe that if we start with the biblical model, we have an advantage in our understanding of science. Now, my guest today is Professor Andy McIntosh with his PhD in combustion theory from the Cranfield Institute of Technology. He has a Doctorate of Science from the University of Wales and is currently a visiting research professor at the University of Leeds in the UK. Now, his research and lectures have led him all around the world, and he's even discussed the laws of thermodynamics with Richard Dawkins on BBC. So what I want you to do is join with me now as we meet my friend and very special guest, Professor Andy McIntosh.
It's a pleasure to be with you.
We love having you. Now
Don't just say you like the accent.
Okay, well,
because of course you're the ones with the accent.
No, well, you might say that, but you are a bit unusual in these neck of the woods down here in Tennessee, you know?
That's right. Well, I like to sort of keep the colonies in order. I hope you appreciate that.
As long as you don't show up in a red coat.
That's right. That might be a bit dangerous. But I'd like to talk to you, David, and all your viewers about science, mathematics, and beauty.
Perfect.
There is just something extraordinary in the way that we're made to appreciate beauty and to appreciate the aesthetic matters of life, including mathematics. I'm not going to give you lots of lectures on differential equations, although they are there if people know about them. But I want to just show you in a way that I trust will be accessible to everyone here.
Sure.
Thus, just the amazing way by which we think. Have you ever thought, where does your mind come from? Is your mind just simply the brain? Many people tried to talk about the ghost in the machine and that sort of approach to the mind, but actually they're missing something deeply.
Okay.
Because your brain is simply the vehicle of a mind which shows that we are made in the image of God.
Oh, wow.
Let me just talk to you about this then. Einstein said the most incomprehensible thing about the universe is that it is comprehensible. Now, he was no friend really to the Christian position, but nevertheless, he was a very thoughtful gentleman, and he knew that we were more than just floating around neurons and matter and molecules.
In other words, if the universe is by random chance, then why can we comprehend so many?
Exactly.
Okay.
The very fact that we can comprehend it at all shows that there is a mind behind it. Now, he didn't believe in the biblical God, but I think he was aware that there was something beyond him. So I'm going to talk to you about the nature of abstract thought, and then I'm going to talk about mathematics and also some of the issues which are connected with it, which are beauty.
Okay.
So what is the nature of abstract thought? Well, C.S. Lewis, who was a famous British atheist initially, then he was converted and realized that there was a God. He says, nature is quite powerless to produce rational thought. Not that she never modifies our thinking, but that the moment she does so, it ceases for that very reason to be rational. For as we've seen, a train of thought loses all rational credentials as soon as it can be shown to be wholly the result of non-rational causes. Let me unpack that for you, David.
Yeah.
I mean, your viewers are very highly intelligent, but I just want to make sure that we've accessed this properly.
Yeah.
If what I am saying is simply due to the eggs that I ate for breakfast, you might then be able to trace all the molecules of the egg and say, well, he's bound to come out with these noises. Well, that would be ridiculous, wouldn't it? If we were going to say that we are just simply the products of our chemistry, or as Dawkins says, dancing to our DNA, then that means that rationality has lost all meaning. And that's what C.S. Lewis is saying here.
Okay.
If we had a big enough computer and could track all that the molecules were doing in your brain, that would really make a nonsense of your rational ability, the way that you think, the way that you brilliantly communicate to others. And Haldane, who was no Christian again, he said, C.S. Lewis, of course, was. Haldane said this: if my mental processes are determined solely by the motions of atoms in my brain, I have no reason to suppose that my beliefs are true. And hence I have no reason for supposing that my brain is composed of atoms.
Ah, because he's using his very
He's using the very thing that he's trying to examine.
Wow.
So you see, he realized that you can't go in this direction.
Okay.
In fact, many others have realized this as well. You're in a quandary of difficulty because you're cutting off the very branch on which you're sitting.
Yes.
It makes a total nonsense. Let me explain it a bit more.
Okay.
When you actually look at the DNA, which we all have, these two guys, John Lennox and Michael Polanyi, I don't agree with all that John Lennox, by the way, proposes. He believes in a long Earth, age-old Earth.
Okay.
So he doesn't take the position that you and I would take on the age of the Earth. But he's quite right on this point. The whole point about the nucleotide bases and DNA is that they may be positioned randomly. If there were any affinities between them, their information carrying potential would be drastically reduced.
Okay.
So information must be information, whether it's in the brain or whether it's in the DNA, simply because it's not due to the chemistry. there is something transcendent, in this case to the DNA, there is something transcendent in our minds, to our brains rather, which is our minds, which is organizing and saying this is where I want the information to be.
Okay.
Polanyi said something very similar. He says, whatever may be the origin of DNA, it can function as a code only if its order is not due to the forces of potential energy. It's the same point expressed differently.
Okay.
It must be as physically indeterminate as the sequence of words on a printed page. So do you get this point about abstract thought?
Yes.
It's a very important point that we need to grasp, that there is such a thing in our experience that we are assuming it all the time anyway. We never really think about the fact that our minds are thinking and that we have rationality. It's assumed that we are thinking straight.
Right.
But where does that thinking come from? It is a sign that we are made in the image of God.
Okay.
Let's come on to the second point. Mathematics, which is dear to my heart. I think the king of everything is theology, but the queen is mathematics. The king and the queen of everything is basically good theology. So we need to understand we're made in the image of God, and we need to think straight. And mathematics is the language of logic. I love mathematics.
I have heard that it said that Galileo once stated that mathematics is the language with which God has written the universe.
That's a very well made quote, very apt what you've just said. I would agree with you. So let me just unpack this a bit more. When you actually make a communication, whether by writing or with some sort of dots and dashes, which we might say is a Morse code, then you don't realize it, but the code and the language is more than the material. This book, which I've written, is more than just the paper and the printing, right? Because that code, that coded system with all the letters, is actually not the material. It could have been put on a computer, and indeed it came from a computer. So
it contains information, but information that only people who are familiar with this language can interpret.
Yeah, English.
Yes.
Not the other.
Oh, come on.
We'll win in the end. But and the message, of course, is also greater than the code. I'm not a great one at French, but it could be translated into French, and I trust the message would be the same.
Yes.
Or Chinese, where the whole alphabet is totally different. So this illustrates an important point that, you see, actually that Morse code is really John loves Mary, but I think Mary would appreciate it written in words, or maybe a hug, to actually make plain what is being trying to be said, communicates with her. It's the same with logic and mathematics. It uses symbols, pi, square roots, and all the other stuff. Yet this message can be very much more powerful than words can explain. Now, I don't know whether you've done maths, David, but maths, when it's done properly, and when you've solved a problem, you have the sense that, wow, that is a pattern, that is clicked, something has really worked. And even the Platonists, the Greek philosophers, who are not Christians, but they had this sense that there was something beyond just what they were doing with the symbols. They could see that there was something which was really powerful in logic itself. And it's said by one of the Greek philosophers, I think it was Archimedes, who said, you know, he suddenly worked out a problem. Eureka, I understand it. And a mathematician really does have this sense that something is really working when he solved a problem. Roger Penrose, who's a clever guy, who wrote the book and The Emperor's New Mind, said, if I've been concentrating hard for some while on mathematics and someone would engage me suddenly in conversation, then I would find myself almost unable to speak for several seconds. This is not to say that I do not sometimes think in words. It is just that I find words almost useless for mathematical thinking. And I've had that sense, even though I'm nowhere near that sort of scale of, you know, progress. But when I've done my problems, when I've worked with mathematics, trying to solve some pretty complicated combustion problem, because that's what I've been working in, and aerodynamics, and yeah, some pretty complicated stuff of acoustics interacting with combustion.
Okay.
Well, there's a huge amount of mathematics, and you try it one way, try it the other way, and then suddenly you get it right. And you can see all the patterns emerging, which are abstract patterns.
Okay.
They're not something which is immediately a painting.
Right.
But they definitely, it's a very similar feel to it. It's a very similar feel to music. And this quote has come from this book, The Emperor's New Mind. I recommend people get it. It's not a Christian book, but he does make the point that the mind is more than just a brain. That's basically, he's talking about the non-verbality of thought itself.
Okay.
Thought is something which shows that you're made in the image of God. In fact, here again, this is no person who was, as far as I know, a Christian. He was the brother-in-law to Paul Dirac, Eugene Wigner.
Okay.
And Paul Dirac was a very brilliant mind. But he talked about the unreasonable effectiveness of mathematics. He says, the miracle of the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift. Where did the gift come from? God himself,
right.
Which we neither understand nor deserve. We should be grateful for it, indeed we should, and hope that it will remain valid in future research, and that it will extend, for better or for worse, to our pleasure, even though perhaps also to our bafflement, to wide branches of learning. Now, he is making here a very significant point, that mathematics has a huge appropriateness, which goes right across all the disciplines, David. And then he says, the great mathematician fully, almost ruthlessly exploits the domain of permissible reasoning and skirts the impermissible. In other words, you're stretching the limits of maths. Just hear me out on this, because people may not necessarily follow all this. His recklessness does not lead him into a morass of contradictions, is a miracle in itself. Certainly, see what he says, certainly it is hard to believe that our reasoning power was brought by Darwin's process of natural selection. In other words, this guy was brilliant.
Yes.
Is doubting that your own mind could have come by natural selection.
Right.
And of course he's right.
Yeah, sure.
The doubt should have been expressed further. Let me take it further.
Okay.
There is an uncanny connection of mathematics across the disciplines. Now get this.
Okay.
You get one equation comes in one discipline,
Sure.
and then suddenly it pops up in another discipline.
Okay.
So this shows, in one sense, that it's almost as though it was the language of God himself. Forgive me for putting it like that. I'm not saying that God thinks in equations. That it's just that when it says in the Bible, in the beginning was the Word, and the Word was with God, and the Word was God. You know that Scripture says that using the word logos,
Yes.
so that he is Christ, who is the Word, is the logical principle behind everything. Hebrews 1 says, he upholds all things by the word. It's actually a different word used there, but it's the same idea, that he upholds all things by the word of his power.
Yes.
So Christ is the one who, if you like, is the logical mind behind everything.
Okay.
And when you get this, I'm not saying that's all of Christ. Please don't think that. I'm not trying to say that it's all just to do with physics, chemistry, and mathematics. Clearly, our God is a spirit, and they that worship him must worship him in spirit and in truth. But even before you get to the spiritual things, everything is telling you that there is a mind which is upholding everything, that everything hangs together. And it really shows up when you now look at the uncanny connections across disciplines.
Okay.
Now, I'm not asking you to understand this equation, but some of our viewers will understand this.
Absolutely.
It may only be, just a few, but some will grasp this, that this is the equation which is a double derivative in space. It describes diffusion, right? So heat diffusion, you've heard of diffusion of heat, diffusion of gases. You look at the astronomy and you see all the diffusion of gases.
All the time.
And they never come back together.
No, they do not, do they?
It's total nonsense. Low-speed fluid flow.
Okay.
So when you're looking at the aerodynamics of airflow over wings. And then there's things like electromagnetism. And basically, that equation will occur in all those areas, even though they're not immediately connected.
Okay.
The same equation occurs.
Works, and you find it
That's
popping
right.
up. Okay.
And so mathematicians say, oh, let's go off and solve this equation, come out with all sorts of solutions, and then they predict what would happen in different situations.
Okay.
And they get it right.
Okay.
Wave equation, you've heard about waves. Well, this is the wave equation. Two derivatives in time and two derivatives in space and the speed.
The speed, yep.
Right? So this would describe the wave of a string. If you and I had a taut string and we were shooting it back and forth, that's what that would do.
Okay.
A wave in a sea, a wave in water. So it describes waves in all sorts of situations across the board. And so we could have waves of sound. We're using waves of sound now, tiny little waves coming through the air. You've got waves of light.
Studio lights.
That's right. We've got waves, radio waves, electromagnetic waves, and water waves.
All around us.
So waves are our common experience. The mathematics of that is described by that wave equation.
Isn't that neat?
It is, but there's more coming.
Okay.
There are fundamental constants in many disciplines which keep on cropping up everywhere.
Okay.
You don't need to worry about the detail. For some of your viewers, you say, oh, actually, you don't understand the symbols. But some will understand that when there are some functions which, when you differentiate them, that's find their gradient, you get the same function.
Okay.
We call that the exponential function. But of course, this is the most important thing. It's the constant called e. It's not any old function raised to that power, not any old base, sorry, raised to that power. It's got to be e.
Okay.
So e is it's the natural logarithm base. It's called e. And it's 2.71828, and it goes on and on. And so we'll put that down there. Just note that for a moment. Now there's another one. Have you heard of the ratio of a diameter of a circle to, the circumference of a circle to its diameter?
Yes.
That is pi.
Okay.
You've heard of pi.
Absolutely.
3.141592653, and so it goes on.
And it goes on.
It goes on and on and on. Now that is, we'll put that down there.
Okay, so
now, are these connected? Amazingly, they are.
Really? Okay.
Because there is another constant which we can't put a number to it, because it's not to do with the usual numbers that you and I use.
Okay.
And this is where it gets a bit complicated and people say, oh, I can't understand this. But let me just explain. There are such a thing as imaginary numbers. You say, well, what's an imaginary number? If you can't have it, then it must, well, just a minute. We don't understand a whole host of things, but we use them.
Okay.
We don't understand even the number pi, because it goes on and on and on, and we just chop it and say, we'll take an approximation. So in one sense, we're always constantly not quite using the exact number that we should be using. The same sort of point applies to this. There's nothing to stop us talking about imaginary numbers such that as long as we obey the rules of the logic which sets them up, we can talk about a number which is both has a real part and an imaginary part. Without going into too much detail here, we find these particularly useful when you've got something which is what we call cyclic.
Okay.
If you've got something which is constantly changing, then we find that the I represents the frequency at which something is going, right?
Okay.
And this value, or the amount of the spread from the zero here, represents its growth or its decay. So it's very relevant to cyclic phenomenon.
Now we can use these types of things in research on fractals and things like that?
It's got some relevance to that, you're right. It does come into fractals, but it does come in particular into when you've got something which is changing and is cyclic, right? So this is the cosine and the sine function. And what we find amazingly, e to the I pi plus 1 is equal to naught. So we've got e, we've got I, and we've got pi, and the figure 1. In other words, these constants, which you'd have thought were not connected, they are connected. So this identity is a very important identity. Keeps on cropping up in all cyclic phenomena.
Okay.
I know this might stretch people's minds, but it's really what we call complex numbers. Non-integers exist, though their precise value is recurring to infinity. I've already mentioned that. So pi, there's the full expansion of pi going to a huge number of digits.
Okay.
But there are fundamental algebraic relationships which go right across the disciplines. You've heard of quadratic equations? You were doing them when you were still in your nappies, probably reciting them, right? Or diapers, as you call them.
That's right.
Yeah, quadratic equations, this formula,
Okay.
right? Well, that's true in every discipline. That's a very fundamental equation. So these don't just apply in one area of mathematics
Okay.
or in one application. They apply right across the board. So the whole area of mathematics is a very, very important matter. Let me give you some other ideas here. There is one equation which has a solution, which is called the golden ratio, and it's this equation: phi squared is equal to 1 minus phi.
Okay.
And the solution to this is, and these are different ways of expressing the same equation, the solution to this is that phi is equal to 0.618.
Okay.
This keeps on occurring in all branches of science. Wherever there is something which is growing and adding a little bit more, then these areas are actually such that this distance to that distance is 0.618.
Okay.
Similarly, this
That
distance to that distance is 0.618.
0.618.
And we found that artists instinctively use 0.618 in order to get beauty. And indeed, our face, this distance to that distance, is somewhere in the region of 0.618.
So
also,
it's
the
inherently-
distance that your eyes are set at in relation to the total height is again about 0.618.
Okay.
Everything is showing that that which is just right and just aesthetically pleasing is connected with this ratio. Architecture is often done with this ratio in mind, as this little video is showing you. Leonardo Da Vinci, of course, is mentioned in there, or inferred in there, because we've got a picture of Mona Lisa, and he had an understanding, as the Greeks did, about this golden ratio.
Yes.
So certainly a lot of the artists were well aware, and a lot of the architectural engineers were well aware of this ratio. So, but you're right, it's connected with this Fibonacci series.
Okay.
Fibonacci was another Italian mathematician, realized that there was a strange sort of series that you could get where you added the two numbers that you just had, add them together. So 0 and 1 is 1, 1 and 1 is 2, 1 and 2 is 3, 2 and 3 is 5, 5 and 3 is 8, and so on. And
Okay.
the numbers go up and up and up, but in a strange sort of pattern, such that any one number is a function of the number before, and the number at one position divided by the number at the previous position gets closer and closer to this number, 1.618.
Okay.
Which actually is the inverse of 0.618.
Yes.
Because that is the nature of this particular ratio.
Like what you're seeing? You can find so much more on the Creation Superstore. You'll find over 900 books and videos on origin science, creation, and Bible history. Whether you're looking for nature documentaries, educational books, homeschool resources, or children's videos, we've got it all, so be sure to head over and check it out. Use the promo code to receive 10% off your first order.
So this occurs amazingly throughout the natural world. Sunflower seeds come out with a number of spirals one way and a number of spirals the other way, which you can see here. You've got spirals going that way.
Okay.
And you've got spirals going the other way.
Coming this way.
And when you look at the number of spirals, both on sunflowers, pineapples, fir cones,
Okay.
you find that there are always some of these numbers that you get in the Fibonacci series.
If you count the rows or the spirals, it always works out in a Fibonacci sequence.
That's right. It's
One of the
always one of those numbers.
Ah, okay.
And this is extraordinary. Now, the golden ratio is not necessarily defined as some would argue, oh, this is just nature sort of getting an optimization.
Right.
It's certainly one solution to the optimization problem. Let me illustrate.
Okay.
If you've got a bunch of seeds in the sunflower,
Yep.
you want to pack them in the best way such you can get as many in as possible.
Okay.
And if you go to this website, actually this chap, David Chandler, whom I know, has actually developed a program which simulates this as to where to put the seeds depending on what type of system you're using.
And 1.618 does definitely work. It's very efficient.
It does work.
But you're saying it's not the only efficient
No,
pattern.
and this is, by the way, the formula that is being used as to
Okay.
where you put the seed. When you add another seed, you're gradually working out and going round.
Okay.
But it's not the only solution. This is the value for 1.618. So there it is again. That's
Okay.
the golden ratio. But you could go to another value which would still fit the seeds in. It wouldn't look as beautiful, but it would work. So there are alternative solutions.
Okay.
So when people try to argue, oh, well, nature is just simply finding the one and only solution, that's not true. There are alternatives.
Okay.
So this indicates that there is beauty which is almost inherently in natural systems.
Wow.
This is a particular example of the golden ratio. Charles Darwin wrote, "A small trifling particulars of structure often make me feel uncomfortable. The sight of a feather in a peacock's tail, whenever I gaze at it, makes me sick." And I tell you why that might be the case. Because when you look at the eye, as we call it, of the peacock feather, it's, apart from it having wonderful iridescent colours, which
yes.
are all due to the fact that there is a slightly different structure in the blue,
Okay.
which is following this barb as it grows and maintaining the structure.
Wow.
But apart from that, the other thing that you should notice is that these distances are often connected with the golden ratio.
Wow.
And so it's not just a circle.
Uh-huh.
It's not just any old oval.
Okay.
It's put there with a sense of the golden ratio as well, giving us that beauty.
Isn't that interesting?
There is more to this. As I've said, artists will always tend to put the centerpiece not necessarily in the center, but
That's
just
right.
slightly off center.
That's right.
And intuitively, they'll do it with the golden ratio in mind.
Okay.
Music is often composed with Fibonacci series. Look at this, 34 measures, 55 measures, 21, 34. And these ratios are often linked with the golden ratio in music.
Okay.
Even some of the music, right? Now, this is perhaps not the best chart to look at because it's a little bit complicated. But if I could just explain it very briefly, the notes on the piano, this is the notes we have today,
Okay.
right? But the original notes, and I'll tell you why they changed in a moment, but the original notes were these, 165,
Okay.
176, 183.33, and A, the third A on the piano is 220,
220.
the fourth A on the piano is 440. Now,
So
if
you
you
have
look,
constants there, but then in between they're
Yep.
different. Okay.
what I was just going to say, David,
Yeah.
is that when you look at the ratio of, if you relate everything to 440,
Okay.
so this is the root octave, right? So this is half the root octave. This is 3/8 of the root octave. And now you look at what's happening.
Okay.
This is 3 over 2 over 2 over 2.
Okay.
This is 8 over 5 over 2 over 2. This is 5 over 3 over 2 over 2, and so on, right? all these numbers are all part of the Fibonacci series.
Okay.
So music and the notes on the piano, particularly when you're talking about fifths, augmented fifths, sixths, minor thirds, fourths, fifths, all music is to do with those relationships. And they're Fibonacci numbers.
Right.
You might say, well, why have we changed? Well, we've got what we call a tempered frequency today,
Okay.
which is not quite that. And I'll tell you why. It's so that you can transpose to a different key. This is fine if you're staying in A, but suppose you want to transpose and change to C, or E flat, or F. You've got to have musical notes such that the gaps are still roughly the same. So that's why today we have what's called the tempered musical scale.
Okay, so
But
you
it's
get a little
not-
bit of a compromise there.
If we've had to compromise in order to transpose.
Okay.
But the original musical scale was full of Fibonacci numbers.
Wow.
I find that wonderful.
It is.
Einstein said, how is it possible that mathematics, a product of human thought that is independent of experience, fits so excellently the objects of physical reality? We might well ask. And Kepler, who is a brilliant mathematician, but also a lovely Christian gentleman, said geometry has two great treasures. One, the theorem of Pythagoras. The other, the division of a line into the extreme and mean ratio. The first we may compare to a measure of gold. The second, and he's referring to the golden ratio here, the second we may name a precious jewel.
Wow.
So Kepler knew that the golden ratio was wonderful. Just to encourage a more simple and more accessible fact about numbers, in the base 10, which is what our number system is.
Okay.
Did you know that 1 times 8 plus 1 is 9, 12 times 8 plus 2 is 98, 1, 2, 3 times 8 plus 3 is 987, and so it goes on.
Ah, look at that.
So let your viewers explore these. Here's another one. 1 times 9 plus 2 is 11, 12 times 9 plus 3 is 111, 1, 2, 3 times 9 plus 4 is 1111, and so it goes
And
on.
so on. Okay.
That is clever, isn't it?
It is. It is.
You can find these. There's another one there, 9 times 9. You get all 8s on the right-hand side.
Okay.
That's because of the base. Now, you'll get other patterns with other use of a different base. If you had a base 8 or a base 6, you get all sorts of patterns.
Sure.
That's just by the way, but it's an example of symmetry. Here's another one. 1 times 1 is 1. 11 times 11 is 1, 2, 1. And so it goes on, and you can see it's going 1, 2, 3, 2, 1, 1, 2, 3, 4, 3, 2, 1, and so on.
Okay.
But that's perhaps a very simple example. But let me just now come to the power and coherence of mathematics.
Okay.
Now, this is amazing. We know that there is a universal nature of maths, but now I'm considering how maths again is coherent in bringing everything together. I'm going to stretch your minds here, and please don't think that I'm going to make this accessible for everybody, because I can't.
I understand.
Because I know I've got some viewers who won't necessarily understand all the detail here.
Sure.
But I want people to see that the mathematics itself is pointing to the existence of a great mind behind the universe.
Okay.
Now, it was Newton who said that he had the feeling that he was thinking God's thoughts after him. And Dirac's equation, remember I mentioned Dirac's brother-in-law earlier, Wigner. Well, Dirac himself did some fascinating work on what's called, as you can see, this is a wave equation. This is the wave bit.
Okay.
But he's got a forcing term on the right-hand side, we call it.
Okay.
And that forcing term is all to do with particle physics. It's to do with really, it's to do with the fact that you've got energy in the system.
Okay.
And that H term, and the H bar term, is Planck's constant. Planck's constant.
Okay.
And so you've got something which is forcing this wave and forcing this wave equation. And it's producing a number of solutions. Now, this is the amazing thing. This is called Schrodinger's equation, right?
Okay.
Now, Schrodinger, we all knew, or at that time, they knew about electrons.
Yeah.
But when Dirac looked at this Schrodinger equation, he realized that there was another solution, which is a positron. And the point I'm making is that the mathematics predicted that there was something else to find.
Ah, okay.
Do you get the point?
Yes.
So mathematics has a predictive ability. It told the experimentalists to go and find the positron, and guess what? They found it.
They found the positron. All right, so help me understand this. Mathematics, it's mostly abstract. It's numbers, it's things that we can, but it works, and we're able to predict.
It's not just numbers. That's the point.
How
Mathematics is not just numbers.
It's amazing.
Mathematics is logic.
Okay.
It deals with numbers,
Okay.
but it deals with representations of physical principles.
Aha.
It's a language which is saying, you know you found this,
Yes.
but did you know there's something else here that you can
Okay.
find? That's what it is. And this is Paul Dirac, the gentleman who found this. He says, it seems to be one of the fundamental features of nature that fundamental physical laws are described in terms of a mathematical theory of great beauty and power, needing quite a high standard of maths to understand it. You may wonder, why is nature constructed along those lines? One can only answer that our present knowledge seems to show that nature is so constructed. We simply have to accept it.
Right.
One could perhaps describe the situation by saying God is a mathematician of a very high order, and he used very advanced mathematics in constructing the universe.
Okay.
Indeed he did. And this is saying, from a person who is no particular friend to the Christian position,
Yeah.
that there is a wonderful glory in the way the mathematics predicts the way the universe is constructed.
You're saying that there appears to be a connection, and there's no reason there should be a connection unless there is some higher power that used these in his construction of the universe and then gave us a portion, just a tiny little fraction of his image, of his mind.
That seems to be what's going on. We are discovering the principles which he constructed the very universe.
Wow.
This is something which relates more to my area.
Okay.
I'm involved in aerodynamics.
Yes.
And looking at the way air goes over shapes.
Okay.
Now, please don't worry about all the detail here.
Yeah.
But the point I'm making here is, and those who know about this work will appreciate it, that this is, if you like, the big equation to solve for the whole of aerodynamics.
Okay.
It's to do with energy, it's to do with momentum, right, of the flow. It involves a number called Reynolds number, which is to do with how fast or how much energy is in the flow compared with the viscous nature of air, right?
Okay.
That's what that really is saying.
Okay.
Now, what Prandtl showed, and he was a brilliant German physicist, he showed that really when you get close to the top of the wing of an aeroplane or just a plate, then really you can say that there are other equations which are more important, which are buried in here, such that when you rescale the distance and make it to be a function of what we call the square root of this Reynolds number,
Okay.
which is measuring how much energy there is in the flow compared with the viscosity, then you find that you get a natural scale which brings out the physics of what's happening near the wing.
Ah.
Now the point is this.
Okay.
You solve those equations, then you have to match them with a solution which basically loses that term, because out here the flow is what we call potential flow.
Okay.
It's quite an easy flow.
Okay.
So you match the solution to that part, and in matching the two together, you find that you can predict the shape of what we call the boundary layer. And this is very important in a whole set of physical principles.
Okay.
This matching of two different solutions. It's like doing a jigsaw, and it has the sense of getting some sort of musical feel about it. When you get everything together, you know, you have this sense of everything working and understanding it.
Yes.
You know, and it's a very musical connection. Mathematics is like patterns in music or like patterns in art. And I've done that myself, just in a smaller way, when I've been looking at some problems where I needed to have one idea linking with a very different idea in another part of the flow.
Okay.
It happened with my work on acoustics.
Huh.
So I very much identify with that.
Yeah.
This is another point which really I just need to stress with you as well. Mathematicians know, those who really study mathematics, and Gödel was a brilliant mathematician. Mm-hmm. He said, for any consistent, effectively generated formal theory that proves certain basic arithmetic truths, there is an arithmetical statement that is true but not provable. Let me put it another way. What he's saying is that there are axiomatic assumptions in mathematics which prove that it requires something outside of itself. In other words, whenever you do maths, there are some things in the mathematics you can't prove, but you know you have to assume them.
Okay.
There is a structure in mathematics which is the very thing which you can't prove, but you have to use it. So it's like saying that there is a transcendental aspect to art and good science. There is a mind behind it. Okay. There is beauty, elegance, and simplicity of mathematical expressions. Let me illustrate. Kepler. Now this is coming to something which I think, again, will be accessible to most of us. You may not understand the formula, but you know that planets go round in elliptical orbits. Right. Well, Kepler, using mathematics, predicted the time period of how long it would take for a planet to go around the sun. Okay. And it's to do with the distance, basically it is from the sun, that's the minor axis over there, that's right, and the mass of the sun, and a gravitational constant, which is Newton's gravitational constant. Okay. And he basically said that the area swept out by the planet in any one time, the area of this, right, going from there to there, would always be the same for a given amount of time. So when it comes round here, it's actually going very much slower than it is when it sweeps round over here. Okay, okay. So it's a very important statement in the solar system. Yes. Here's another equation. This is a well-known one.
We've all heard this one, yeah.
E equals mc squared. You know about that. Well, most people know that that is Einstein's equation. It looks so simple, and yet it's describing something utterly amazing. Energy and mass
the speed of light
are related to each other, and nobody knew that before. Everybody had said that conservation of mass, you know, mass is always going to be the same. And he said, no, it's energy. It's energy which is always the same, and some mass can be given out as energy. And of course, Hiroshima and Nagasaki proved that.
Good example, yes.
Very sad example, but that was shown, of course, to be the case. How about this one? This is Maxwell. Now, Maxwell was a brilliant mind, and he took the equations of electricity and magnetism. He died, I think, around 50 years old when he died. He was a brilliant man from Scotland. And he, just using mathematics, predicted, even before it was found out, that light and electromagnetic radiation is actually a formation of an electro wave and a magnetic wave, an electric and a magnetic wave. Okay. It has a dual nature.
Predicted it.
And he predicted it. And what's more, he predicted the speed at which that wave would go. Okay. Do you see what I mean about the predictive ability of mathematics? The predicted speed could be calculated using just straightforward measurements of two quantities, the electrical permittivity of free space and the magnetic permeability of free space. Okay. And in a brilliant leap of scientific insight, Maxwell showed, using a very succinct mathematical model, that light was composed of electricity and magnetism. And this was the brilliant finding. He predicted the speed of light would be about 300,000 meters per second. And that's exactly what it is.
Wow.
That's one of the best examples of the predictive nature of maths.
Yes.
Well, let me close off here.
Okay.
This mind, whom I've mentioned before, Roger Penrose, said a beautiful idea has a much greater chance of being a correct one than an ugly one. So E equals mc squared, Maxwell's equations with this beautiful solution of the equations, which looked quite complicated. He reduced it to a very straightforward. I mean,
what appears to be simple, but it's still profound.
Exactly.
Okay.
So this is an important principle. That when you've got it right, it's going to look beautiful.
Okay.
Now look, compare this with Dawkins, who's not a mathematician.
Right.
The universe we observe has precisely the properties we would expect if there is at bottom no design, no purpose, no evil, no good, nothing but blind, pitiless indifference. When somebody asked Dawkins, you know, what's your brain?
Yeah.
Where did your mind come from? Yeah. My friend, who happened to meet him in Oxford High Street, was told, my brain is just a lump of meat. So he had a very low view, not only of God, because he doesn't believe in him, but he has a very low view of himself. And when he said that, he was saying something very, very sad. Because tyrannical regimes which do not believe in God and just believe in just random matter, random molecules producing you, have often justified their tyranny by an appeal to this idea, which of course is wrong. This is Schindler's List, which reminds us of the Holocaust, which of course Nazi Germany was built around these ideas, which have come from Darwin.
Yes.
Stalin and many others were also thinking the same.
Countless millions of lives, because people were convinced that human life really means nothing. We're nothing more than an accident, a cosmic speck, a lump of meat.
And yet their own minds are telling them differently if they were only to just reflect on the brilliance of what they have. Famously, Nietzsche, whose thinking really led to what became the terrible Nazi system in Germany eventually, but he was living way back in the 1880s. But it led to the rise of a different type of Germany, which was leaving its Christian roots, okay? And he said, God is dead, God remains dead, we have killed him, his shadow still looms. How shall we comfort ourselves, the murderers of all murderers? And he was basically talking there of a cry of despair.
Yeah.
He was basically saying, we've got rid of God in our thinking, but what is the meaning to everything? It's really what he was coming out with there. Of course, he died, and he died really, I think he was almost mentally ill when he died.
Wow.
In 1900, age 55. Compare him with Maxwell. Do you see the huge contrast?
Absolutely.
Maxwell was a Christian who humbly served God, who actually used his mind in a brilliant way. Nietzsche died in a sort of state of disrepute and disrepair and despair as well.
Yes.
Somebody wrote on the wall, Nietzsche is dead.
He is.
See, God has the last word. Let me just close off also by showing you that this is a famous German philosopher. Mathematics is a rock upon which naturalism, the idea that we're just all matter, founders. If non-naturalistic Platonism is yet to stand a chance, and he's not really yet going to the idea of God, but he is saying that there must be a transcendent mind, then it is in the question of the existence and nature of mathematical entities. Let me just move it on because I want to bring it to a close here.
Sure.
Remember we talked about Wigner.
Yes.
He said this point, which we mentioned earlier, that it's hard to believe that our reasoning power was brought by Darwin's process of natural selection. In a lecture in 1847, Michael Faraday said, speaking of his science, therefore our philosophy, used as we would now say our science, whilst it shows us these things, should lead us to think of him who has wrought them or made them. For it is said by an authority far above even that which these works present, that the invisible things of him from the creation of the world are clearly seen, being understood by the things that are made, even his eternal power and Godhead. Faraday had the right attitude.
Yes.
He was humbly, simply discovering things which he understood the physical principles behind them. He understood that there was a mind he had been given and used that mind.
Mm-hmm.
Maxwell did the same.
That's right.
This is where true science beautifully fits, and mathematics, although Faraday wasn't a mathematician, but Maxwell was.
Yes.
Mathematics is a part of this. When you get things right, they advance proper, coherent understanding of the world around us.
And the fact that they are interconnected and can be comprehended by our brain, yet they transcend that, they're found all throughout nature, points to someone greater.
Indeed, and the mathematics itself speaks of beauty. Remember, it's connected with music and with art. Remember the golden ratio and all these things in the, just with numbers, but it applies even in the equations. You get a beautiful equation which encapsulates all the major physics, and you know you've got it right.
Right.
This is the way that good science advances.
So you wrote a book called Genesis 1 through 11, a verse-by-verse commentary. It's a short, easy to understand book that looks verse by verse at the book of Genesis.
It does.
It looks at it as literal history.
It does.
A lot of people would say it's nothing more than fairy tales, the result of, old writers over thousands of years, just scribbling down things. But even it holds the foundations and the principles to all of the physics and mathematics at play in the universe today.
Absolutely. And my other book, Genesis for Today, talks about how we should approach Genesis and science. So it has a chapter on this, which you might find helpful as readers pick up this book. They will see that there is a whole set of chapters on each issue, and how we approach Genesis and science is the second chapter. And there's a lot of science in the back of this book.
Excellent.
So they might find it helpful in giving a foundation, as you just said, for doing their science.
These resources are so powerful. We've seen so much today that, again, I don't believe it could have happened by chance.
No.
Thank you so much for being here, and we're going to have you back on some future programs.
It's a pleasure to be with you.
Yes, sir. Well, we've seen some pretty amazing things today, and it seems that around every corner we find more and more evidence of God's handiwork at play. I don't think that all of the design, beauty, and complexity we see around us is an accident. Looking up, truly, the heavens declare the glory of God. Hello, I'm David Reeves, host of the TV show Creation in the 21st Century on TBN. Each week we talk to some of the world's leading scientists, all